Hey guys, Mr. Milton here. Today we're looking at simplifying radicals number 3, fractions. Okay, at the end of this video, you should be able to simplify radicals involving fractions, and you should be able to rationalize the denominator of a fraction. Okay, so far, we've talked about simplifying radicals with numbers and simplifying radicals with variables. So let's look at that just as a recap a little bit here. So radical 52, remember our rule was we would break it down, try to see what multiply to give us 52. So I can think of 26 times 2. That's 13 times 2. And 13 is a prime number. So I have a pair of 2's. It goes to the outside. 13 doesn't have a pair. Stays on the inside. Radical 52 would simplify as 2 radical 13. Okay. With variables, how we approached it was we said, okay, let's deal with our p's and our n's separately. We're looking for pairs of p's, so we could divide the exponent by 2. And so when we look at 7 divided by 2, that gives us 3.5. So we'd see, okay, we have 3 pairs of p's, p to the third power, and one that wasn't quite a pair, so it's by itself and remains inside the radical. N to the 10th, 10 divided by 2 was 5. So we had 5 pairs of n's. So our rule, multiplying outside by outside, we have p to the third times n to the 5th, and inside times inside, only p is left on the inside. Our simplified radical here would be p to the third, n to the 5th, radical p. Okay, let's look at division here. This is new for us. Okay, the division property of radicals is that if we have radical a over b, that's the same as radical a over radical b. Okay, and vice versa. If we have radical a over radical b, we have radical a over b. Okay, so basically the same rule with multiplication where we said inside times inside, outside times outside, goes with division too. Inside divided by inside, outside divided by outside. Okay, here are 2 problems. We have radical 9 over radical 25. As we approach this, we're going to use our method that tells us, hey, this is the same thing as radical 9 over radical 25. You might ask, like, why would you want to do that? Well, 9 over 25 by itself doesn't really like simplify to a nice number. It simplifies to a fraction or a decimal, which we won't use decimals here. And so when we separate as radical 9, we can say, well, what's the square root of 9? 3. Radical 25, what's the square root of 25? 5. So radical 9 over 25 is 3 over 5. Okay. As we look at number 2, we have radical 5 over radical 16. Sorry, radical x to the 5th power, over radical 16. Okay, so I'm looking at the x's. How many pairs of x's do I have? Well, 5 divided by 2 is 2.5. So x squared with an x that doesn't have a pair. Radical 16, what divided by, or what times itself gives us 16? It's 4. Okay. All right, so we have x squared radical x over 4. Okay, and now we've simplified radicals in fractions. Okay, here's the rule with radicals. You can never have a radical in the denominator of a fraction. Remember, that's the bottom. Why? Because some math people way before our time said that, and so we follow that rule. Okay, so in the 2 examples above, did we satisfy this rule? Yes. You'll notice that in the denominator, our first answer was 5. In the denominator of our second answer is 4. Okay. Remember that as you take the square root of 16, it is 4. A lot of people make the mistake of saying square root of 16 is square root of 4. Okay, but it's not. We took a pair of 4's out of the out of the radical. Okay, so the radical doesn't need to be there at all. Okay. And then why? Well, you'll notice that radical 25, radical 16, they're perfect square numbers. Okay, so we did it without even having to really think about doing it too much. But what happens if it's not a perfect square? Okay, we have radical 75 over 12. Okay, in this problem, in the denominator, in this problem, is the denominator a perfect square? And the answer here is no, it's not. Okay, what do we do then? Well, the number inside the radical is a fraction, and sometimes fractions can be simplified. Okay, once we do that, let's see that. Let's simplify this fraction, okay? Because up here, we wanted to separate it because we had a perfect square in the denominator. And so we separated it and took care of it. But here we don't have a perfect square, so we'll try to simplify it. What goes into both 75 and 12? As a look at that, 3 goes into both of those. So when I simplify this fraction, I have radical 25 over 4. Okay. So once we do this, the new fraction inside this, the radical is 25 over 4. And so now we'll notice, hey, radical 25, radical 4. What's the square root of 25? 5. What's the square root of 4? 2. So 5 over 2. Okay. Let's look at a couple more examples using that. So here, number 1 on this page, we have radical 15 over radical 27. So we'll simplify. What goes in both? 3 does. Okay, because 27 is not a perfect square. Okay, so radical 5 over radical, radical 9. Okay, because we divided by 3. We didn't take pairs out, so still a radical. Okay, and so now we notice that, hey, on the bottom, we have 9. Square root of 9 is 3. Square root of 25 is only 5 and 1, so we can't really break that down any further. Our answer is radical 5 over 3. That's our final simplified answer. Remember, it is okay to have a radical in the numerator. It is not okay for us to have a radical in the denominator. So this is a good answer. Number 2, we have 100x cubed over 18x to the 9th. Okay, again, we don't have a perfect square in the denominator, so we want to simplify before we do anything else. Let's simplify this fraction and hope that we can get there. Okay, so between 18 and 100, I see there's a 2 that goes into both of those, so I'm going to divide both of those by 2, 50 and 9. And x to the 6th and x to the 9th gives me x to the 6th on the bottom. Sorry, x to the 3rd and x to the 9th, x to the 6th on the bottom. Okay, so now I'll notice that, hey, on the bottom of this fraction, I can rewrite this as radical 9x to the 6th over radical 50. Radical 50 over radical 9x to the 6th. And so square root of 9 is 3. Square root of x cubed, or x to the 6th is x cubed, right? So we're just simplifying that like we did before. And then radical 50 is 25 times 2. 5 times 5, we have a pair of 5s and a 2. So 5 radical 2. Okay, and so that's our answer. 5 radical 2 over 3x cubed. So if the number in the denominator is not a perfect square, you simplify the fraction, and if simplifying the fraction still doesn't give you a perfect square, what do we do? After reducing the fraction, we still have, in this problem, let's look at this, we have radical 50 over 6. So we can say not a perfect square in the denominator. Let's simplify. So then we get radical 25 over radical 3. And the numerator is a perfect square, but really remember, that's not what we're searching for. We want our denominator not to be a radical, because if we have a radical in the denominator, we can't write it as a final answer. So after reducing, we still have a number in the denominator, or a radical in the denominator. We have to now, what we call, rationalize the denominator. Rationalize, new word. We'll use it a lot. Okay. Here's how we do that. As we look at this, we have radical 25 over radical 3, and we can say, hey, 25, that's the perfect square, 5, radical 3. Again, this is not a good answer for our final answer because we can't have a radical in the denominator. So we have to rationalize. This is what we do. We will multiply the top and the bottom by, and I like to call it fancy 1. Okay. Because what we're doing when you multiply by 1 is you're just keeping the same value. 10 times 1 is 1. 17x times 1 is 1. 10 times 1 is 10. 17x times 1 is 17x. When you multiply something by 1, you're not changing its value. Okay, here we're going to multiply by 1, but we want to change how this problem looks without changing its value. And so this is what we're going to do. Call this fancy 1, and this is how you can tell how fancy 1 looks. We're going to multiply this, because it's radical 3 in the denominator, we're going to multiply this fraction by radical 3 over radical 3. Okay, explain really quick why I call this fancy 1. Anything divided by itself is 1. You can type it into your calculator. 2 divided by 2 equals 1. If you did it x divided by x, that equals 1, right? Or it gives you like x to the 0, which is 1. Remember that? Okay. So anything divided by itself is 1. So radical 3 divided by radical 3 is 1. You might say, well, how's multiplying by 1 help us out? Well, let's look at it. 5 times radical 3 gives us 5 radical 3. Radical 3 times radical 3 gives us radical 9. You'll notice, hey, this is a perfect square. And that's not a coincidence. Anytime you multiply a radical by itself, you'll get a perfect square number. So as we simplify, we have 5 radical 3 over 3. And this is what we want our final answer to be, because there are no radicals in the denominator. So let's look at these last two problems. We have 7 over 3, radical 7 over 3. Can't simplify it any further. There's a radical in the denominator. We need to multiply by fancy 1. In this case, fancy 1 will look like radical 3 over radical 3. So we multiply that, both inside the radical. So this gives us radical 21 over 3. So that's our final answer, radical 21 over 3. Looking at number 2, I'll quickly say, remember, we cannot simplify this fraction because 10 is outside of a radical and 6 is inside of a radical. Okay, remember, inside by inside, outside by outside. That works with addition and multiplication and division. So we can't simplify, so we go straight to using radical 1. Radical 1, in this case, looks as radical 6 times radical 6, because that's what we're trying to get out of the radical here. So radical 6 times radical 6 gives us 6. 10 times radical 6 gives us 10 radical 6. Remember, outside times outside, inside times inside. And so now as you look, you'll see, wait a second, we have 10 and 6, and they're both outside of radicals. So we'll see, can we simplify this? And in this case, we can. We can divide both of them by 2. And so we get 5 radical 6 over 3. Okay, remember, we cannot simplify 6 and 3 because 6 is inside the radical and 3 is outside of a radical. All right, these can never be combined. Okay, just a couple more problems here. We have a to the 4th over a to the 9th. Let's simplify. Okay, so this is just a division problem, minus 4. We get radical 1 over a to the 5th, or radical a to the 5th. Okay, so as we look at this, we will simplify the denominator and the numerator. Radical 1 is 1. This gives us a squared radical a. What do we have to do here? Well, we have to multiply by fancy 1. In this case, fancy 1 looks like radical a over radical a. So when we do that, we get a squared times a, which is a to the 3rd, and radical a on the top. So we have radical a over a to the 3rd. Remember, we cannot simplify this any further because 1 is inside the radical, 1 is outside of the radical. And then number 4, as we simplify, 12 and 5 don't simplify, but our x's do. So we have radical 12 x to the 8th over 5, or radical 5, sorry. Okay. And so I can simplify this top a little bit. It goes into 12, 3 and 4, 2 and 2. So I have a pair of 2's. X to the 8th, that's 4 pairs of x's, and a 3 without a pair. Okay. In the denominator, I have radical 5, and I need to use fancy 1 to get the denominator from being a radical. So I'm going to multiply the numerator and the denominator by radical 5. So in my denominator, radical 5 times radical 5 gives me radical 25, which is just 5. In my numerator, I have 2x to the 4th, radical 3 times 5, 15. So my final answer, 2x to the fourth, radical 15, over 5. Okay. We'll spend a couple days on these fractions so we understand it, and we understand rationalizing the denominator pretty well. But then after that, we should be good with simplifying radical expressions. We talked about numbers, we talked about variables, and now we've talked about fractions. All right. Okay. That was rationalizing denominators and simplifying radicals with fractions. See ya.